For over a decade now. I mean, the tech world has basically chanted this one almost hypnotic mantra, right? Cloud
Oh,
first.
yeah, completely. It was the only acceptable strategy.
Right. It was presented as the ultimate destination for literally every company on Earth. And, the promise was completely irresistible.
Infinite scale.
Exactly. Infinite scale, zero hardware headaches, and a beautifully streamlined budget. But today, if you look past all that marketing, there is a quiet rebellion happening.
A very expensive rebellion, I might
Yeah,
add.
yeah, seriously. That whole promise of infinite scale is suddenly giving executives a massive, multi-million-dollar financial hangover. So that is our mission for this deep dive.
Yeah.
We are taking a whole stack of industry analyses, expert insights, and cloud economics research to evaluate a surprisingly complex shift,
Yeah.
moving workloads back to on-premise infrastructure.
Right, which the industry calls cloud repatriation. And honestly, we are seeing a structural reversal that very few analysts predicted even like 5 years ago.
Yeah, the numbers we're seeing in these sources are frankly staggering. I mean, up to 80% of surveyed enterprises are currently considering repatriating some of their workloads back to their own hardware.
And in the UK, it's actually, well, 25% of organizations have already moved half or more of their cloud workloads back to on-premise systems.
Which is wild, because moving half of your infrastructure isn't just, tweaking a budget.
No, it's a fundamental dismantling of a long-term strategy.
Yeah.
It requires immense effort. So that tells you the pain of staying in the cloud has finally exceeded the pain of leaving it.
Exactly. So if you're listening to this and you happen to manage an IT budget, or maybe you're prepping for a technical strategy meeting, or, honestly, if you're just insanely curious about the invisible infrastructure running our digital lives.
Which is all of us, really.
Right, literally everyone.
Yeah.
Understanding this massive shift is absolutely crucial, because questioning default narratives is how you stay well informed.
Completely agree.
So, okay, if the monthly bills are this bad now, I'm trying to figure out how IT leaders ever convinced their CFOs to sign off on this 10 years ago. Like, what was the original math?
Well, it all comes down to a financial concept that basically dominated boardrooms about a decade ago. CapEx versus OpEx.
Capital expenditures versus operating expenditures.
Exactly. Businesses were just thrilled by the idea of not having to buy physical servers up front, because buying a server is a capital expenditure.
Right.
It's expensive, it depreciates, and it just sits in a basement, taking up space and electricity.
It sounds kind of like switching from buying a massive fleet of company cars to just giving everyone an Uber account. Like, you only pay for the rides you take.
That was the exact logic. They thought moving to an operational rental model would save them a fortune. So the strategy that took over the industry was something called lift and shift.
Oh, I saw this in the notes. Lift and shift.
Yeah. Organizations took massive numbers of legacy application software that was explicitly designed to run on a physical server, and they just picked up the code and the data and dropped it right onto a public cloud provider.
Wait, so they didn't rewrite the code to make it more efficient?
Not at all. They just transplanted it. And this is where the financial model completely backfired.
Oh, wow.
Now, to be fair, the cloud is phenomenal for truly cloud-native, highly variable workloads. Like if you're a startup building from scratch.
We're running a massive e-commerce site that needs to handle Black Friday traffic spikes, right?
Exactly. The elasticity is magic. The problem isn't the cloud itself. It's putting unoptimized legacy applications into a cloud environment.
So if I'm understanding this right, it's basically like taking a highly inefficient 1950s refrigerator, picking it up, plugging it into a modern, highly sensitive smart grid, and then being completely shocked when your utility bill bankrupts you at the end of the month.
That is exactly it. It perfectly captures the friction between the software and the environment. Because you have to look at how the public cloud actually bills you.
Right.
It operates strictly on a utility model. In your own data center, a server is a sunk cost. You buy the hardware, and whether it runs at 10% capacity or 90% capacity, your cost is essentially the same.
But the cloud is different.
Very different. The cloud charges you for every single compute cycle, every byte of storage, and, every single network interaction.
So these 1950s refrigerator applications are just churning away doing basic background tasks, but they are burning through utility resources 24/7.
Yep, and the financial fallout of that continuous burn is severe. The research shows companies are currently paying an average of 2.5 times more in operational costs than they initially projected.
2.5 times.
And in worst-case scenarios, it's up to 3 or 4 times more.
That is insane.
I mean, they expected operational savings. And instead, they created a financial black hole. And the irony is, while they were busy renting virtual servers for a massive premium, the cost of physical hardware plummeted over the last decade.
Right. They missed the other side of the hardware equation because it's now vastly cheaper to just own your own high-performance servers than to rent virtual ones.
Especially if your applications are just running at a steady state and don't need that magical elasticity we talked about.
Yeah, hardware has become incredibly powerful and remarkably cheap.
If you have predictable workloads, owning the metal wins the math almost every time now.
So the baseline utility costs are bad enough. You're renting something that's cheaper to buy and you're running it inefficiently.
Right.
But reading through these sources, what is truly driving technical leaders to the breaking point aren't just those baseline costs, it's the hidden junk fees that they never budgeted for.
Oh, the junk fees.
And the biggest offender here seems to be data egress fees.
Egress fees are arguably the silent killer of enterprise cloud budgets, because cloud providers make it incredibly easy and absolutely free to move your data into their ecosystem.
Right, that's called ingress.
Exactly.
Right.
But the moment you want to move that data out, say, to a hybrid on-premise system or to a partner's network, they charge you massive fees.
Wait, I have to ask, why is moving data out so expensive when putting it in is free? I mean, is there an actual massive technical cost to the provider to send data out over the internet?
No, not at all.
So it's purely a business penalty.
It is overwhelmingly a business strategy. The actual physical cost of bandwidth and routing for these hyperscalers is fractions of a cent, but they mark it up astronomically.
Just to keep you locked in.
Exactly. It functions as an artificial moat. Businesses didn't fully model this when they signed their initial contracts.
Wow.
So what seems like a simple, necessary transfer of gigabytes between a cloud provider and an internal system can quickly spiral. Organizations are opening their monthly bills and finding tens, sometimes hundreds of thousands of dollars in surprise charges.
Just for accessing their own data.
Just for moving their own data.
It's the classic Roach Motel business model. You know, data checks in, but it costs us an absolute fortune to check out.
That's a great way to put it.
And then there is the other major hidden cost, which is unexpected scaling charges. Now, here's where it gets really interesting, and I have to push back a little on this one.
Okay, go ahead.
Based on everything we've ever been told about the cloud, shouldn't auto-scaling be a good thing? I mean, isn't the entire point that it automatically gives you more computing power exactly when you need it?
So your business doesn't crash during a spike in traffic, right?
Yeah. Like, isn't that the killer feature?
This raises an important question, because scalability is a fantastic feature in theory. But let's look at the context of how it actually functions without strict FinOps.
FinOps meaning cloud financial operations.
Yes, the practice of bringing actual financial accountability to the variable spend model of the cloud. Without rigorous cost governance, auto-scaling just acts as a mask for fundamentally bad architecture. Well, let's look at the mechanism. Say your 1950s legacy app has a memory leak.
Okay, so a flaw in the code that causes it to consume more and more memory over time.
Right, so the app is getting sluggish, and eventually the code trips a CPU threshold. The cloud provider's algorithm doesn't know you have bad code.
It just sees a massive spike in resource demand.
Exactly. It assumes you are getting a huge surge in legitimate user traffic. So it automatically spins up 5 new virtual servers at, say, $4 an hour each.
Doing absolutely nothing but hosting that same bad code.
Precisely. Instead of the engineering team fixing the underlying bottleneck, the cloud just happily throws endless, highly expensive capacity at the problem to keep the app running.
That is wild, because the cloud providers have absolutely no incentive to tap you on the shoulder and say, hey, your code is broken, you should fix this.
None at all.
Because that broken code is directly inflating their monthly revenue.
They are essentially monetizing your technical debt. As long as your inefficient application demands more power, they will gladly sell it to you automatically and continuously.
Okay, so let's say an enterprise realizes this. They see they are bleeding money through egress fees. They see auto-scaling is masking their bad code. And the baseline cost is like 2.5 times higher than expected.
The panic sets in.
Right. So the logical next step for any rational business leader is to pack up and leave. But actually executing that exit reveals what the sources describe as a virtual hostage situation.
Yeah, leaving the cloud is notoriously difficult because of severe vendor lock-in. And it really operates on two fronts.
Okay.
The first is purely contractual. Companies are entangled in these complex, multi-year enterprise discount programs. They promise to spend a certain amount over 5 years to get a discount, and breaking that agreement requires massive financial payouts.
Ouch. And the second front seems even stickier based on the research. It's the technical entanglement.
Yes, the native service entanglement.
Right, because over the years, developers didn't just host their code in the cloud, they started tying their applications to proprietary native cloud services.
This is a crucial point. Instead of using standard open-source databases or universal security protocols, developers started relying on native APIs.
And let's define that really quickly for the listener. An API, or application programming interface, is essentially the language or bridge that allows different pieces of software to talk to each other, right?
That's exactly the way to think about it. And cloud providers offer their own incredibly convenient but entirely proprietary APIs and database tools. They are unique to AWS or Google or Microsoft.
Okay, I see where this is going.
When your engineers build an application using those specific tools, the code becomes hardwired to that specific cloud provider's ecosystem.
Oh man, it sounds like renting a luxury apartment, which is great, but then you decide to build a giant custom piece of furniture right inside the living room.
Right into the walls.
Yes, you build it right into the walls, and then your landlord triples the rent. You want to move out, but it is physically impossible to fit that custom furniture through the door.
So you either have to stay and pay the tripled rent, or completely dismantle and destroy the furniture to leave.
Exactly. That captures the friction perfectly. To leave the cloud, you often have to completely rewrite your application from scratch to untangle it from those proprietary services.
And because of this massive friction, the contract penalties, the application rewriting, the egress fees to extract the data repatriation is often kept highly confidential by enterprise leadership.
Yeah, the sources mention the secrecy specifically. Why is it such a closely guarded secret? Like, if everyone is feeling the pain, why aren't companies openly talking about leaving?
Because bringing workloads back is widely perceived by the market and by the board of directors as an admission of a massive strategic mistake.
Ah, right.
You sold the board on this 10-year cloud-first vision. You spent millions migrating there, and now you have to walk into a room and walk it back.
That's brutal.
One of the sources actually noted a company that only finally triggered their repatriation project after their cloud spend hit a staggering $300 million.
$300 million. I mean, I can't even fathom the meetings leading up to that decision.
It's painful.
But despite that pain, the return on investment of leaving must eventually make sense if the hardware is getting so cheap.
Oh, the ROI of leaving is becoming undeniable for many core workloads. The cost of buying new, high-performance physical hardware for an on-premise data center or renting space in a managed colocation facility alters the math entirely.
Just to clarify, colocation, that's when a company rents the physical space, power, and cooling in a massive secure data center, but they bring and manage their own physical servers.
Correct. Rather than renting virtual space from a cloud provider, you get the enterprise-grade facilities without the utility model pricing on your compute power.
Makes sense.
And over a 5 to 10-year horizon, owning that hardware frequently justifies the massive upfront ransom of paying the egress fees and rewriting the applications.
Wow.
In fact, the payback period for repatriation can sometimes be as short as 18 months.
Okay, so let's pivot to what this all means for the leaders on the ground. For the technical leaders, the CIOs, the CTOs who have done the math, taken the hit to their ego, and decided they absolutely must repatriate.
It's a tough road.
Because managing the actual transition sounds like an absolute nightmare.
It is arguably one of the most difficult transitions an IT leader can manage. And surprisingly, the servers, the hardware, the coding, that's the easy part.
Really?
Yeah. The real challenge is managing the human element. You are going to face massive cultural whiplash within your engineering teams.
Oh, I hadn't even thought about that. You have employees who have spent the last 5 to 10 years being trained and certified exclusively on public cloud architectures.
Exactly. Their entire professional identity and their resume are built on AWS or Azure. They are cloud engineers. And now leadership calls a meeting and tells them they need to retrain to operate physical on-premise hardware, configure actual routers, and manage private networks.
You are taking someone who considers themselves at the cutting edge and asking them to troubleshoot bare metal.
There is often huge resistance and attrition because of this.
So how does a leader actually handle that? You mentioned earlier the sources suggest establishing a cloud center of excellence, which I'll be honest, sounds a bit like corporate jargon.
It does.
What does that actually look like in practice?
Well, it sounds like a committee that meets once a month, but it needs to be the exact opposite. A true cloud center of excellence is a highly empowered tiger team.
Okay.
You don't assign this to your operational B team. You take your absolute best engineers, the ones who truly understand the architectural nuances of both the cloud and traditional infrastructure.
Right.
You put them in charge, you give them actual overriding authority to veto bad decisions, and you let them guide the recovery or migration process.
And the sources highlight a strategy called stopping the bleeding. How does a company actually do that when they're halfway through a massive, sprawling migration without, taking their core business offline?
You have to freeze feature development. If a migration, whether it's moving into the cloud or repatriating back out of it, is currently failing or wildly over budget, you stop immediately.
Just hit pause.
Do not push through hoping the economics magically fix themselves. You pause, reevaluate the architecture, and look at how the data flows between systems.
The sources mention implementing proper DevOps and zero-trust security protocols before restarting. Can we break those down really quickly?
Absolutely. So DevOps is the integration of your development team and your IT operations team. It means creating automated, reliable pipelines so that when a developer writes code, it is automatically tested and deployed safely.
Got it.
If your DevOps pipelines are a mess, moving locations will just result in a faster mess.
Right, that makes sense. And zero trust.
Zero Trust Security is a framework that discards the old idea of a secure corporate perimeter.
Like instead of a castle with a moat where everyone inside is trusted.
Precisely. Zero Trust means the network automatically assumes every connection, every device, and every user is a potential threat. And it verifies them constantly, even if they are already inside the system.
Wow.
You have to build these foundational practices into your architecture before you resume moving workloads.
Okay, and while a leader is figuring all of that out, they have to be incredibly careful about who they ask for advice. The sources were very clear on this, beware of vendor advice.
Oh, yes.
Because the consultants sent by the hyperscalers, the big cloud providers, they are not neutral third parties in this transition.
They are inherently monetarily conflicted. Their primary goal, naturally, is to keep your workloads on their platform and increase your consumption of their services.
Of course.
So if you ask a hyperscaler consultant how to lower your monthly cloud bill, their solution will almost always involve buying into a different, more deeply integrated service they offer.
Which only deepens the technical entanglement and the vendor lock-in we talked about earlier.
Exactly.
It's like, never ask a barber if you need a haircut. So the leaders really have to check their egos at the door. I mean, if the cloud strategy failed because of a lift and shift approach, you have to own it. Trying to cover it up or kicking the can down the road by throwing more auto-scaling at bad code just leads to compounding technical debt.
And eventually, those demoralized engineering teams who are tired of managing a broken system are just going to abandon the company. If we connect this to the bigger picture, technical resilience isn't just a matter of signing the right legal contracts or arguing over server locations.
Right.
True resilience requires leaders who possess the intellectual honesty to pivot based on actual, measurable business value. They have to look at the data and be willing to ignore the multi-billion-dollar marketing hype that insists cloud first is the only valid modern strategy for every single workload.
It really is a fascinating reversal. We've traced this whole journey today from the unoptimized 1950s refrigerator lift and shift era that led to ballooning costs to the hidden traps of egress fees that penalize you for moving your own data.
Yeah.
We dug into how auto-scaling actually triggers and monetizes technical debt. We looked at the daunting hostage-like reality of vendor lock-in through proprietary APIs. And finally, we unpacked the vital leadership strategies, checking egos, managing the massive cultural whiplash of retraining staff, and stopping failed migrations needed to successfully navigate a repatriation back to physical infrastructure.
It is a powerful reminder that technology cycles always fluctuate. The centralized mainframe gave way to personal computers, which gave way to the centralized cloud.
Right.
What is the unquestioned standard today will inevitably be challenged tomorrow when the underlying economics change.
And if you're listening to this, whether you are building a scrappy startup from scratch, managing a massive enterprise IT budget, or simply trying to understand the economics driving the modern internet, this is your takeaway.
Yeah.
Questioning default tech narratives is the ultimate superpower of the well-informed. You don't have to accept the absolute supremacy of the public cloud just because everyone else is repeating the mantra.
It requires critical thinking, looking at your specific application needs, and ignoring the noise.
Exactly. Which leaves me with a final thought for you to mull over. We've seen that dedicated servers and on-premise infrastructure are becoming the new standard for cost efficiency and data control. So what if the ultimate future of global computing isn't a massive, centralized public cloud owned by 3 major corporations at all? What if the future is actually a highly decentralized, hyperlocal web of private edge computing centers that companies entirely own and control themselves? Something to think about the next time you plug in that 1950s refrigerator